Hello intellectuals, I am Thakur and you are watching this video in Digital Maths Academy.
Time decides who you meet in your life. Heart decides who want in your life. But behavior decides who will stay in your life. Hello everyone, I am Thakur and you are watching this video in Digital Maths Academy. In the previous video, I had already explained about the function. What kind of relations are called function? Under what condition a relation can be a function? How to check whether the given graph is a function or not. In this video, I am going to explain the types of function. Let's get started. In the types of function, the first of all, here it comes onto or surjective functions and into functions. Okay, right? So onto function, little bit I had explained in the previous video as well. So in onto function, we see the codomain and the range both are equal, but in into function, the range is subset of codomain, both are not equal. So we can define it like this, we can understand it in onto functions. Every element of the codomain is the output of some elements from the domain, and here input functions at least one element of codomain doesn't have pair. So you can see that here D doesn't have any pair, here C doesn't have any pair. So we can say these two functions are called into functions, or we can say that they are one-to-one into functions also, we can say, right? So very soon I'm going to explain about one-to-one function as well, but right now we can say it's an into function, that's onto function, right? Codomain and range both are equal in onto function, and here codomain and the range are not equal, or range is the subset of codomain. Moving forward, we have one-to-one functions, that's injective. One-to-one function means injective, right? So in one-to-one function, we can say that each input is paired with exactly one output value. So 1, 2, 3 are inputs and 4, 5, 6 are outputs. So we can say that each inputs, right? Each inputs has only one, that single output we can see, right? So we can say that now here all the elements of the set A, right, have unique element in the set B. Image is not repeated, right? So, and we can see that here 4 doesn't have pair, but A, B, C, all the elements of the set A have one element in the set B. So it's also called one-to-one, but we can say one-to-one into function, we can say such type of functions, right? One-to-one into, and it's one-to-one onto. Moving forward, we have here bijective functions. Bijective, right? A function that is both one-to-one and onto, isn't it? So sometimes we see that sometimes the function may be one-to-one, right, and the function will be onto as well, right? So we cannot say any function is into, right? All the output has one pair. So if the function is one-to-one and into, one-to-one and onto, right? One-to-one and onto, then such type of functions are known as bijective functions. And one thing just I like to remind you that we can find the inverse of bijective functions only, okay? If the function is many to one, if the function is into, the inverse is not possible. So inverse of the function, which is both one-to-one and onto, can have inverse only, right? Going forward, we have here many-to-one functions, right? So many-to-one functions, as the word explains, right? 1, 2, 3, right? We have input, and 1 and 2, the elements have only one image, that is 1, A, 2, A, we can see. So such type of functions are called many-to-one. Here also you can see that A, B and C, right? All the elements of the set A have only one image in the set B. So A, P, B, P, C, P, right? So such type of functions are called many-to-one functions, right? And such type of functions doesn't have inverse, so we cannot find the inverse of many-to-one functions, right? Now next one is that algebraic functions. So what kind of functions are known as algebraic functions? Okay, so algebraic functions means a function containing algebraic expression are called algebraic functions, right? That is fx is equal to x plus 5 to x minus 4. And there are some functions in algebraic functions. They are, the first one is constant functions, isn't it? It's constant functions. So constant functions means what kind of functions are known as constant functions? Just we we have a look here. We see we have only one image for all the input, right? So 1, 4, 2, 4, 3, 4, right? So every input has the same output, isn't it? So we have same image for all the domain. Then such type of functions are called constant function, right? And we can, when we draw the graph of such type of functions here, then you can see. So here 1, 4. So 1, 4. Yes, you can find here 1, 4. Then 2, 4, 2, 4 here, 3, 4, 3, 4. Yes, you can write here, right? And when you draw the graph here like this, isn't it? When you draw graph, then we see that the line is parallel to x-axis, correct? In this case also minus 2, 5. So minus 2, 5, it comes here. 0, 5, just 0, comma 5, right? So 0 and there's a 5, this point, and 4, 5, there's 4, 5, isn't it? So if we draw the line, then the line will be parallel to x-axis. You can see that. So the constant function is always parallel to x-axis. Not to forget that. Constant function is always parallel to x-axis. So moving forward, we have identity functions, right? So in the identity function, we see that inputs and outputs are equal. 1, 1, 2, 2, 3, 3, isn't it? So if the domain and the range are equal, such type of functions are called identity functions. And here you can see that 1, 1, 2, 2, 3, 3, right? So when we find the points in a graph, then 1, 1, see that here, 1, 1, of course will be here, right? 1, 1, 1, 2, 2, right? 3, 3, isn't it? And when you draw a line, have a look here. When you draw a line, of identity function, then you can see the line is passing through the origin, isn't it? And the line is bisecting the positive x and y axis and negative x and y axis, right? So we can say this angle is 45 degree, right? This angle is your 45 degree. We can say that this angle is 45 degree, right? That's bisecting, isn't it? So this line is passing through the origin and bisecting the axis. So now moving forward, so linear functions, right? Linear functions. So linear functions means it's an algebraic functions, right? As identity function and constant function. So in linear functions, we have to understand that it is a function of algebraic expression of degree 1. Likewise, y equals to fx equals to 2x plus 3, or y equals to x minus 5, like that. If the degree of the algebraic, degree of the variable is 1, then such type of functions are known as linear functions. Yes. So when you draw the graph of linear functions, then we can see it's also a straight line, right? Here, y equals to 2x plus 3, we can see, and we can find the 3 points in the line, that is 0, 3, 1, 5, and minus 1, 1. And when we show all the points in a graph, then we see that we can get a straight line. So linear function means it's a straight line, right? The next one is, the next part of the function is quadratic functions. So in the quadratic functions, actually, we see the graph of quadratic functions like this, right? And we can define quadratic functions like this: a function which is in the form of y equals to x squared plus bx plus c, or a should not be equal to 0, because if a becomes 0, then it won't be quadratic, it becomes a linear equation. So here I have shown you the graph of y equals to x squared minus 2x minus 6, and then you can see the graph of this quadratic equation. So I'm going to explain how to sketch, how to draw the graph of quadratic equations when I teach you this chapter. That's a curve, right? So moving forward, we have another is cubic functions. In the cubic functions, we see a function which is in the form of y equals to fx equals to ax cubed plus bx squared plus cx plus d, and a should not be equal to 0, then the function is known as cubic function, and this is the graph of cubic function, that is y equals to x cubed. So again I will explain this function in the curve, right? The next one is the next part is trigonometric functions. Trigonometric. Trigonometric means a function containing trigonometric ratios are known as trigonometric functions, right? For example, fx equals to sin x, f equals to cos x, f equals to tan x, fx equals to sin x plus cos x, and how to draw the graph of such type of trigonometric functions, that is sine, cosine, tangent. I will teach you in trigonometry when I will be drawing the graph of such type of functions. In this chapter, I am just going to explain the types of functions, so I am not going in detail whether this is trigonometric functions, linear functions or not. So I am just going to explain about this. So you may have liked this video, so not to forget to like, share, and if you are new, not to forget to subscribe my channel. Thank you everyone. God bless you. Good luck.